which we are going to start is work, power, energy. Okay, so in this chapter we will discuss the concept of work, energy, the potential potential energy has two kinds of energy, the kinetic energy, potential energy. Then we will discuss the power, okay, and related problems. Okay, so the first we will see the introduction of work. Okay, so what is work? So you can see a person who is walking on the ground and holding an object. So whether he's doing a work or not, so that we will discuss. These things we are going to discuss. Next, a man sitting on a computer for 12 hours a day. A man carrying a heavy load on his head and standing under the sun for hours together. So a man sitting on the computer and working for 12 hours. Okay, so this we call these things as work, but in physics these are not called work. A man carrying a heavy load on his head and standing under the sun for hours. So it may be called as work in day-to-day language, but in physics this is not work. Okay, so can you say that they are doing work? Normally we can say they are working hard, but in physics they are not working. Okay, so why they are not working? Because there was no displacement in the above two cases. Okay, so if a person is just standing and if a person is just working on computer, then there is no displacement, there is no work. In physics we have special definition for work. So work is said to be done by a force when a body undergoes displacement parallel to the line of action of force. Okay, so parallel means, or component of force we can say, is either force or component of force is parallel to. So we can write better, we can write force or component of force, means the whole force may not be parallel. So component of force parallel to displacement, only then we say the work. So if you see this person is sitting on the computer, so it will not be a work, but this is the work. If the person is applying a force and the object is moving, the object is having displacement in the direction, some part of displacement in the direction of force, then we will have the work. Okay, so definition of work. How do you define a work? The work is done by a force when a body undergoes displacement with some component parallel to force. Means displacement, you since vector displacement and force both are vector quantity, so it is not necessary that displacement is always in the direction of force. So you should have at least some component of displacement along the force, only then you can have the work. Okay, so not necessarily all the part of displacement will be along the force, means the force will be perfectly parallel to displacement, but if you have even some part parallel to the force, some part of displacement parallel to force, you will have some work. So for force and displacement along straight line, if they are along a straight line, we can simply write work equal to force into displacement. No need to write components because they are along the same straight line. No need to consider vector. Simply we can write force into displacement as work. When force and displacement are in vector form and constant, then work is given by F into S dot product, F vector S vector dot product. So Fs cos theta. That you can see in the diagram. Means suppose the force is acting like this. So component of force in horizontal direction is F cos theta, and displacement is along horizontal. The force is applied like this at some angle theta, but the object displaced along horizontal with displacement S. So the F cos theta is component of force parallel to displacement. So F cos theta into S we can say as work. Okay, so F is not acting perfectly parallel to S, but you have some component of F parallel to S, that is F cos theta. So you multiply the F cos theta part, the component of force parallel to displacement with displacement, and you get the work. Okay. Now I have illustrated the same thing here. Since the body is being displaced in direction of F cos theta, see F is here and F cos theta is along the horizontal. So displacement is along F cos theta. So you have to multiply these two things, the F cos theta with S. So work done by force in displacing the body through distance S is given by F cos theta S. Okay. Or we can say that the work done is equal to scalar product or dot product of the force with the displacement for vector quantities, if the force and displacement are given in vector format. Work is a scalar quantity and its CGS unit is dyne centimeter or erg. How it is coming dyne centimeter? Dyne is corresponding to the force. So force into displacement. This is force, dyne is force, and C is displacement. So dyne is force and C is Cm is displacement. So force into displacement is going to give the erg. Okay, so erg is also unit of energy. SI unit of work is Newton into meter. The force is Newton, meter is the displacement. So Newton into meter also gives the unit also called joule. Okay, so joule is the unit of work and which is also unit of energy. So 1 joule is 1 Newton into 1 meter. And if you convert it in CGS unit, it will be 1 Newton is 10 to the power 5 dynes and 1 meter is 10 to the power 2 centimeters. So it will be how much? 10 to the power 7 dyne centimeter, or 1 joule is equal to 10 to the power 7 ergs. Okay, so this is the conversion between CGS unit of work and SI unit of work. The 1 joule is equal to 10 to the power 7 erg. Okay, now we will see types of work. What are the different types of work we know? So first we will see